Okay, welcome back to CSE 142, beginning of our fourth week. I remembered today to include our question of the day, so it was, what kind of eggs do you prefer? I'm glad to see that scrambled won. I was surprised that fried eggs ended up so high. But anyway, that was our response to the most recent question of the day. Again, you can suggest your own question of the day if you're interested by going to the engagement activities link on the class webpage. So we're finishing up some material from Chapter 3 that we skipped in order to be working on the graphics. And we're going to be moving into some material from Chapter 4 today. We'll finish it up on Wednesday, and that's when your new homework assignment will be passed out. So let me switch to JGrasp, and I want to spend a little time in the interactions pane. So we'll do some things here. I thought I would remind you of something that I mentioned last week, which is that the approach that Marty Stepp and I decided to take for the textbook was that we wanted to emphasize what's known as procedural style programming early, and that basically we're doing objects late, is kind of the idea. That turned out to be the popular approach, in terms of which Java textbooks sell. The objects late books are the ones that sell the best. But part of that idea there was that we were going to practice using objects. That's kind of what we're going to do early, is using different objects. That's not surprising. Java is an object-oriented language, so there's a lot of objects floating around that we might want to work with to do things for us. So we've seen that drawing panel is a kind of object that we can manipulate. Graphics is a kind of object that we can manipulate. You're practicing that with homework 3. Strings are objects that can be manipulated. We haven't said a lot yet about what can be done with strings other than printing them and concatenating them, but we'll get to talking some more about strings. Today, what I want to talk to you about is working with console input and output. And there's going to be something new in here. So I think I've mentioned this a couple of times, but I'll remind you of it, that think about what's going on when we say system.out.println, and maybe hello, something like that. What happens when we're giving a command like that? Well, system begins with a capital S, so that's the name of a class. And I think I showed the documentation of this last time, that inside the system class, you could think of it as that there's a variable inside the class known as system.out. And system.out is storing a reference to an object that does what we call console output. It sends output to this window that we see here that we refer to as the console. So you have been manipulating an object actually since Chapter 1. I just didn't talk a lot about the fact that it was an object. But you've been talking to an object called system.out. The commands we've been giving that object are print and println. So we've been sending it messages that are print and println style messages, and it behaves appropriately, sending output to the console. You may have noticed it, I didn't point it out, but it kind of went by on the screen when I was showing the documentation for the system class. But it's also not surprising to guess that this would be so, that there's something called system.in. So there's kind of a corresponding object for doing console input. And this is one of those places where Java is just very odd. It seems like there were a team of people who put together Java, and some of them had very different kinds of attitudes about things. It seems like whoever did system.out had a very different life view than whoever did system.in. The person who did system.out made it a very easy to use object. We didn't have to worry about errors happening. It's just kind of very relaxed kind of object. And so system.out is great. We love it. It's very easy to use. We teach it from Chapter 1. System.in, by contrast, is just really hard to use. And there's a lot of cases where you have to worry about possible errors that it makes you deal with. It just was never something that was going to be very easy for novices to use. So those of us who were using Java, in the early days when we were teaching Java, we would write our own classes. We would make our own, like the drawing panel class. We would create our own class that would allow you to do console input more easily. So something to kind of substitute for system.in. And I had friends who taught at Stanford who went over, Sun Microsystems had designed Java. They went over and talked to people, on the Java team, and they kind of said, why don't you guys fix this? Why don't you do what we're doing and provide people with something that's easier to work with? And the people at Sun basically said they didn't care. They didn't care that it was hard for novices. They said, this is a professional strength programming language. It's intended for professional programmers. Why are you teaching it to novices? So their attitude was that this was our problem and not theirs. There was something that changed that, and it was kind of a corporate rivalry or corporate intrigue, I guess you could call it. What ended up happening is that when Java started becoming really popular, Microsoft decided that they would do Java. So they started, creating software using Java. But they found that they didn't like a lot of the things like java.abt. They didn't like a lot of those libraries. So they did the kind of thing that Microsoft always does, which is they created libraries that worked on Windows machines and only on Windows machines. And this really pissed off the people from Sun Microsystems. Sun owned Java at the time. There was a slogan they had for Java: write once, run everywhere. Write once, write once, run everywhere. There was a joke people made about this: write once, debug everywhere is what people said the actual reality was. But in any event, they were really angry that Microsoft would create something that only ran on Windows machines. That's not the Java philosophy. It's got to run everywhere, so you're not allowed to do that. They sued them. There was a nasty court fight over it between them. I remember talking to some Microsoft folks at the time, and they told me that they weren't allowed to use the J word. They'd almost whisper, Java. They weren't allowed to say Java out loud because the lawyers told them to be careful about that. So what did they do? They created something called C#, and it was kind of their alternative to Java. Then there were issues of, well, is C# a ripoff of Java? And the Microsoft people said, no, it's our own brand new language, and it really came more from C++. This is one of those things where I think it would be fun to have a simulated kind of a talk show about this. There's a guy named Maury Povich who's famous for having talk shows where he brings on, a couple, and the woman says, the child, it belongs to him, and he says, I'm not so sure, there's this other guy or whatever, and they do a paternity test. I think it'll be fun to do that with Microsoft and Java and C#. You kind of bring Microsoft out, here's my baby C#, and it's saying, and here's C++, the father, definitely C++ was the source of this, and they bring out Java, and whoa, the kid really looks a lot like Java, and then it's kind of, a big fight. Is it, whose child is it? And Microsoft says, well, I had an affair with Java in the early 90s. It ended badly in court, whatever. It's really C++'s child. It would be interesting to see. I mean, I'll give you one little example. In Java, we say public static void main string bracket args, as the way to have a header for a main method. C#, it's very, very different. You say public static void main with a capital M, and you say string bracket args with a lowercase s. So, hey, very different, maybe not quite so different. In any event, Microsoft got in the game with their thing called C#, and one of the things that turned out to be good for all of us is that set up a competition between C# and Java. So C# had some interesting features that Java did not, including good console input. So Microsoft got that right. They provided kind of a nice facility for doing console input that made it easy. And so then the folks at Sun Microsystems felt they had to respond. So if you look, there's Java 5 was kind of the release where Sun was catching up to Microsoft. They were it's the kind of have a lot of C# features in it. So it went the other way too. Is that things that Sun did, you could see as copying what Microsoft did. I don't care so much about the rivalry and the lawsuits. What matters to me is that this competition is good for us, because it means that good ideas that come out of both companies end up as part of the language. Well, so one of the things that Java did as a result of all of this is that they added something called the scanner class. So that's a new class that was added with Java 5, kind of the catch up with C# version of things. And the scanner class has greatly simplified the things that we'll do in order to do input in lots of different areas. We're going to see this for file input as well. But today we're talking about console input, this little window where we've got an interaction going on with the user. Scanners are very flexible, we're going to see. So I'm going to set up a scanner variable. I'm going to say scanner console is equal to a new scanner. Now, again, I can use any name I want here. I could call it X, I could call it, a scan, I could call it anything I want. I'm going to call it console because that's just a good name for indicating the kind of input that I expect to be processing. But there's nothing special about the console name. You can use whatever name you want. This is just kind of what I tend to do when I'm doing a console scanner. And when you set up a scanner, you have to tell it where it's reading from. So it doesn't always read from system.in. That's what this one's going to do. It's going to read from system.in, but we're going to see that we can set up other scanners that read from other sources. That's one of the nice things about scanners, is that they're more general purpose than just doing console input. So we'll set up this variable called console, and it says to me a little warning that it can't find the scanner class. We've seen this before. Remember, this happens because I needed to do an import. So the scanner class is in a package known as java.util, a set of utilities. And so java.util is what I have to import in order to be able to execute that line of code to set up my console scanner. Okay, so that has constructed my console scanner. So now I want to talk to it and kind of show you what it does. And I think you've gotten used to this by now, that what my co-author Marty Estep and I do is whenever we introduce a new kind of class like this, we give you a nice slide in the slide deck, and it'll be in the book too. There's a nice table like this that tells you about different methods that can be used with the scanner class. So for example, there's a method called nextInt, reads a token of user input as an int. So let me come over here and say console.nextInt. So let's give that command. So I'm saying, hey, console scanner, I want you to execute your nextInt method. That's kind of what I'm saying. And I'm not going to put a semicolon because I want to see what value it returns. This is like those math class methods. It returns something. So I hit enter. Well, notice there's a little dashed box here. That's because it needs to read. It needs to read from the console. So, and that's this little window here. So what JGrasp does is it's a little weird when you're in the interactions pane to kind of have the console separate from the interactions. And that's why it made the little dashed box to kind of indicate it's waiting for some input. And you can type, say some leading spaces and then something like 319. So suppose I type that in and hit enter. So when you make calls like this, if the console scanner doesn't have any input to process, it will pause and wait for you to type in an entire line of input. So when it pauses for an entire line of input. It waits until you hit the enter key before it continues on. So, and it showed you, that's the return value. It showed that it returned the value 319. We could do it again, and maybe this time I'll type some tab characters, tab, 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 and then a bunch more spaces, even than I'd done before, and a 42, and then some tabs and spaces afterwards. And I'm going to hit enter, and again it read in a 42. There's a notion that we have of what we call white space. So here I type some tab characters and I type some spaces. Those are all things that separate what we call tokens. You could think of them as words. So, basically I typed a bunch of white space and then I typed in a 42. And the console scanner will skip past the white space. It pays attention to it to figure out what the individual tokens are, but otherwise it skips it. What do you suppose happens if I do this? And this, I wish I could have students give me responses, because it's always interesting to hear people's theories about this. What's it going to do when I ask it, when I give it 37.3? It's going to skip the white space, and it's going to come over here. I sometimes get the answer from people that they think it'll read the integer part, the 37 part of this, and then stop. That it'll see that that's an int, it'll read that in, and it will just stop right there. But that's not how the console scanner works. So if we come back over here and see the way it's described, reads a token of user input as an int. So these methods, next int, next double, next, they always read an entire token. So they're not going to read just part of a token like this. It can't read just the 37. It's got to read the 37.3. So it reads in that whole token, 37.3, and it says, can I interpret that as an int? And the answer is no. It can't interpret 37.3 as an int. So this is going to give us an error. When I hit enter, we get an error. We haven't talked about this a lot. It's going to start coming up for you with chapter 4, with this program 4 that we're going to do. So it's told you that what we have here is an input mismatch. So that's the kind of error that occurred. These errors we refer to as exceptions. So in the terminology in Java is that the Java code throws an exception. It kind of stops the program from running. It says, that was not okay. That was an input mismatch. You told me to read an int, and that was not something I could interpret as an int, so I'm going to throw an input mismatch exception. Here, we're in the interactions pane here, so it didn't kind of stop things from running. If this had happened in a program, the program would have stopped running. So when an exception like this is thrown, the program halts. It just stops running, and it reports the error to you. But here we can keep going because we're in the interactions pane. Once an exception is thrown by an object, the object kind of is under no obligation, what it will do next. You could imagine, for example, a device, sometimes there's a little red light that comes on or something, error, on a device of ours or something, and we have to reset it, or we have to, turn it off and turn it back on again or something to clear the error. The scanner's a little more forgiving than that. So the scanner is kind of, it says, look, I can't do what you said. I can't interpret that as an int, but it will let you try again if you're in the interactions pane. So in the interactions pane, I'm going to now give it the next double command instead. So I'm going to tell it to go ahead and do console.nextDouble, and it gives me 37.3. Notice that time it didn't pause. The reason it didn't pause is that 37.3 was still sitting there waiting to be processed. We're going to talk about this more later when we get to chapter 6, but the model that Java uses is a plumbing model. So you kind of imagine a pipe that has data in it, and that 37.3 was still in the pipe waiting to be processed. So that's what we get when we do next double. How about if I typed in 13? What's it going to do? That's an int type value, not a double. So you might imagine that it would give an input mismatch exception. What I think about for each of these is I kind of imagine, well, in this case, what if I had said int n equals 37.3? Or down here, if I'd said double n equals 13, what would have happened? You can try that yourself if you haven't already. We talked about it a little bit in chapter 2. I said that you didn't have to know quite yet. I'd remind you that when these details start becoming important. If you were expecting an int, then a double is not going to work, because it would have to chop off part of the double in order to make that work. So if you were expecting an int, a double is not okay. But if you were expecting a double, then an int is okay. So Java, if you said double n equals 13, that's okay. Java's willing to turn an int into a double because there's no loss of information when you do that. And so here we can see 13.0 is what it ends up returning. But if I was to say something like hello, when you were expecting a double, that doesn't work. That's another input mismatch exception that we get there. So next int, next double, how do you suppose we read in a token? I'm always interested in hearing students' answers to this as well. I think next string would have been a pretty nice name to use, int double string, or next token would have been a nice thing to use, even next word, something like that. But what you'll see on the slide over here is that it just is called next. So it's not quite as parallel as we'd like, but it's just the word next. So that reads the next token as a string. So let me go ahead and hit enter, and it read in the word hello. Suppose I do it again and I say 4.7 years ago. So it read in, I should have paused. I meant to let you think about it for a second. I typed in a bunch of tokens, and then it called console.next. Console.next reads a single token. And so the white space matters, the spaces that I put in there. So that's why the first token it encountered was the word for. I don't know why it's not. I thought it would be selecting just the token. But anyway, that's kind of the first token. The next token it's going to find is the word score. And then it's going to find the word and. And then this doesn't have any letters in it, but it's surrounded by spaces. So that's a token. It reads that. And this looks like an int, but it can be read as a string. It's kind of hard to tell. It's going to say a 7, but really it's reading that as a string. Notice how it's not pausing. That's because I typed in a bunch of words. They're all in the pipe. It's kind of waiting. And so what's left in the pipe to read is years and ago. If you really do want to read more than one token at a time, there's another method called next line that reads kind of from here to the end of the line. So right now we've read all this other stuff, but we haven't read this part of the line, the years ago. So if I do console.next line, it's going to read those last two tokens. So it reads in years ago. It reads an entire line of input every time you call next line. We're not going to be using that one just yet, the next line method. We're going to use the token-based methods, the next int, next double, and next for now. But we'll get to a point where we're going to do the next line. Okay, that was one of the things I wanted to talk to you about today. Let me do something. I wanted to fix up this program we were working on Friday. So there was this program on Friday where you specify kind of a ball going in a certain direction, and we used cosine and sine to figure out the different components and so forth, kind of simulate a ball traveling, and it draws white balls where white dots where it's been before, it shows you a little black dot where it is currently. So that was a little program we wrote. I gave it some slightly different numbers than we were working with on Friday. An even nicer thing to be able to do, instead of just going in and changing numbers like that, would be to have a scanner. So I'm going to say scanner console equals a new scanner that's connected to system.in. And here, instead of setting velocity to a specific number, I'm going to say console.nextDouble. So I'm going to make a call on console.nextDouble. Here I'm going to make a call on console.nextDouble. I was using kind of integer angles, but you really want to allow somebody to be able to use a decimal point there if they didn't want an integer angle. But I did kind of have in mind that the seconds would be an int, so we'll do console.nextInt. So let's go ahead and see if that compiles. We get an error message, cannot find the scanner. Why can't it find the scanner? Well, remember there was the import issue. So I'm going to have to come up here and import java.util.star. So you may import from more than one package. So we want the AWT things to be able to do the graphics, and we want util to be able to do the scanner. So we can try compiling, and then we can try running this. so that now it should be allowing me to type in those numbers instead. I'm sure it'll start up before too long. I have thought maybe this Mac's getting a little old. I should replace it, but boy, it's slow. Why is it so slow? Why is it not doing anything? Well, I'm doing this on purpose. I'm kind of acting stupid on purpose. It's waiting for me to type in a double. So it's waiting for me to say something like, I want to be at 38.4 degrees. And, I want to go at, say, 319.4 pixels per second at 38.4 degrees for 10 seconds. So it was waiting for me to type in numbers like that, which would then be used to run the simulation. Well, this isn't a very friendly way to have the program behave. So what we tend to do is to add some extra lines of code that we call prompts, a prompt. So I'm going to say system.out. Not up here. System.out.print velocity with a question mark. And then we're going to close that. And then here I'm going to say system.out.print angle with a close quote. And here I'm going to say system.out.print seconds with a question mark. And then let's go ahead and recompile and run it again. And you'll see that what happens this time is that that text appears, the little velocity question mark. You'll notice that I used a print command. That's the usual thing for prompting, is to use a print command, so that way the cursor is positioned at the end of the line right here. So suppose that I wanted, a velocity of 400 pixels a second, and how about an angle of 40 degrees, and let's go for 20 seconds. So those prompts are nice. They're kind of, reminding me of what it is I'm supposed to be entering. And zoom, there it goes. We didn't get to see very much because it ran off the screen pretty quickly. All right, as I said, I want to do a few more things. One of the other things that I wanted to talk about, because it's in the chapter, so I want to talk about the idea of cumulative sum. Normally, I would be warning you that this is going to be on the midterm, or that it's likely to be on the midterm and the final. But I think it's still worthwhile to remind you of these things. Because remember, if you go on to 143 after this, you're going to be competing with people who took the version where it was on the exams and people studied it a lot. It's also just, it's not just arbitrary. These are important things to understand. Cumulative sum is a pattern that comes up often. And so it's kind of good to know how to do something like this. So suppose you wanted to add up the numbers 1 to 1,000. Suppose you wanted to know what the sum of the numbers 1 to 1,000 is. There's a famous story about the mathematician Gauss, that his teacher wanted to punish him by making him add up the numbers 1 to 100. And he supposedly came up with a formula, then you're kind of immediately told the answer, and the teacher was a little annoyed. We could do that. If we had math people in the room, we could do that. We're going to do it the programming way, which is to kind of use brute force and just add them all up. So this would be a great place to use a for loop. Int I equal 1, I less than or equal to 1,000, I plus plus. And there's a certain pattern that comes up in cumulative sum. Part of the pattern is that you have a line of code that looks like this. Sum equals sum plus something. So the idea is that we don't need to know all of the intermediate sums. There's going to be a lot of sums along the way. We only need to keep track of a current sum. So what we're going to do is we're going to take the old sum, add something to it, and make that the new value of sum. And then we've forgotten the old value of sum, which is fine. So we're always kind of keeping a current sum, and then that becomes the old sum the next time round, and we add something else in, and then that becomes the new sum. So in this case, we're going to want to say sum equals sum plus, and the things that we're adding up are these values that I takes on, 1, 2, 3, 4, 5, up to 1,000. So that's the way we're going to want to write that code, is that sum is assigned to sum plus I. And then another thing about the cumulative sum pattern is that after a loop like this, you would use the sum, whatever it is you want to do to use the sum. In our case, how about if we do a system.out.println sum is equal to sum. So suppose that we're just going to report what the sum is equal to. I haven't declared this variable sum. And so think about it for a minute. Think about where would it be appropriate to declare it. We could declare it inside of here. That's a possibility. That's not going to work. That's not going to be a good way of doing it. Well, think about it. I've been mentioning the idea of scope. So if you declared it here, its scope would be the curly braces that contain it. So it would be visible inside the for loop, but it wouldn't be visible outside of the for loop. In particular, it wouldn't be visible here. So this is not going to work if we have it in here. Another thing about putting it in here is that the right way of thinking of this is that every time it enters the for loop, it kind of would recreate the sum variable. It would make a new version of the sum variable. And that's not what we want. We want to have the old value of the sum variable used to compute a new value. So we don't want it here. That's not the right place to have it. So the right place to have it is going to be in the outer scope. Declare it before the for loop. So we can have our int sum there, declare it there so that its scope is the scope of the outer method. That means it'll be visible here, but it'll also be visible here. I think you guys probably know this isn't going to work, but let's go ahead and compile and we'll get the compiler's verdict. Variable sum might not have been initialized. So it's complaining about this line of code right here. Well, it's kind of saying, look, the very first time, when I is 1, the very first time into this loop, it wants to take the old value of sum. Well, what is the old value of sum? We haven't computed any sums yet. And so it kind of says, take the old value. Well, we didn't give it a value. So that's got to be fixed. We have to give sum a value. And we want to set it to a value that's not going to affect the sum. I mean, if I set this to 38, then my sum is going to be off by 38. And I think most of you can see we'd want to set it to 0, because 0 is additive identity. It has no effect on the sum. So adding in a 0 is not going to change anything. Or another way of thinking of it is that when I is 1, we want the old sum to be 0, so that then it adds in a 1, and then sum becomes 1. And then it adds in a 2, it adds in a 3, it adds in a 4. So this is that cumulative sum pattern, is start a sum at 0 outside of a loop, do the sum as assigned to sum plus something inside the loop, and then use the sum after the loop. That's the cumulative sum pattern. It's in the notes. It's in the chapter. We'll see it in a lot of sample problems. As I said, I normally would be telling people that there's a high probability that it would be on the midterm and even possibly on the final. So we care about this. We want you to practice it and know how to use it. Here I can compile and run this version of it. And here's what it figured out for me was that's the answer when you add up the numbers 1 to 1,000. Okay, that's pretty good. That's the cumulative sum. Now what I want to do is I want to think about what would happen if I wanted to have this in a method. So what if I wanted a public static void method that would sum up to some maximum? That's kind of the generalization of what we're doing here, right? We're summing up to 1,000, but what if in general you wanted to sum up to some maximum? Let me take these lines of code and cut them from here, and I'm going to paste them in here. So what if what I did instead was that I was going to call sum to max, and I have my sum variable in here, but I need to have a sum variable here as well, so I could kind of add my int sum up here. So that's kind of what I have in mind. I hope that by now you're noticing this isn't going to work out. We've got to fix this up, but that's what we've been talking about and practicing. I mentioned that it's all about the idea of information flow, and there's two big ideas: how to get a value into a method, and how to get a value out of a method. So those are kind of the two sides of that, of the flow, going in and coming back out again. So we can actually get a hint about what's going to go wrong here by hitting compile, because the compiler gives us some feedback. We're back to being told that the sum might not have been initialized. And you say, well, wait a second, what do you mean it wasn't initialized? We initialized it to 0, we added a bunch of stuff in, it added everything up, so sum was initialized. But remember, that's this sum. That's the sum variable that's over in that method, and this is a different variable called sum. So they each have a local variable called sum. And yeah, we did a good job over there, but over here, our variable sum is still not initialized. You could imagine setting it to 0, but that's not going to work well, because that's just going to report a sum of 0 here. That means it's going to compute this other sum, but that other sum never ends up being used. So this is a case where this method has done a useful computation for us. It has figured out what the sum is that we were looking for, and it's supposed to use that sum somehow. Now, I mean, it could be printing. We could bring the print command into here, but we want to be able to do this in a flexible way where we could be doing other things than printing it. And so what we want to do is to figure out, look, there's a value, I've computed it, you need to remember it later. This is a case where I want to get a value out of a method. And how do we get a value out of a method? We were talking about it last time. We return. So I'm going to return the sum from this method. That means that the return type is going to have to change. So not public static void. I think all the ones that we did before were public static double. We looked at a lot of things where the return type was double, but this is an int return type. So, it's not always double. Sometimes it's int or other things. So we're going to write sum to max as something that returns an int. So now I've modified this method so that it's passing a value back to main, but I haven't fixed up main. So it's like now the pizza delivery person is coming to the door and ringing the doorbell and saying, I've got a pizza for you, but we're not doing anything with the value that's being returned. So we call sum to max, it's returning something, but we didn't do anything with it. Remember, what we want to do with it, say, is store it in a variable. So that's how sum's going to get its value, is that I'm going to have the method return a value back to main, and then when it comes back, I'm going to store it in main's variable called sum. That's how I'm going to get the sum that's over here into the sum that's over here. And then I'd be able to report it. Well, that's one change I want to make. Another change I want to make, let me go ahead and uncomment these lines of code because I wanted to throw in our scanner idea that I'm going to have it, ask for an int, that would be like, how many of these things do you want to add up? And so I'm reading in a max. So I wanted to kind of compute up to some kind of a max. Here the max was 1,000, but so if I want to have a max that's over here, be used over here, then this is that other side of the information flow. This was the information flow to get something out, and we used a return. How do we get something into a method? Remember, that was what we used parameters for. So with parameters and returns, those are the two sides of the information flow coin. So we've got a thing called max here. We need to pass it in as a parameter. So we'd have to have something like int max here in order to be able to have the value flowing into this method. Again, you don't have to call it max. You could call it anything you want. But, actually this I think is a good name for it, calling it max. And then, of course, we'd have to change this so that that's using that max. Well, let's go ahead and compile that version of it. And then let me go ahead and run that version of it. So if I say I want you to add up to 1,000, it gives me a sum for that. And if I ran it and I said I want to add up to 10, it gives me a smaller sum. If I want to add up to 813, it gives me a much larger sum. So that's good. I mean, we wrote a nice method, flexible method that takes different values of max. It returns it back to main. We split up our program into a main and a method. So this is a good little model. It's a little mini model of the issues we've been talking about, the information flow we've been talking about, parameters flowing into a method, return values coming out of a method, using those return values to assign a value in main. So anyway, that's yet another little example to study. It'll be on the calendar for today. Okay. I'm going to switch this up because I want to do a slightly different thing with you, which is all that other code we had there, that's going to be on the calendar in its own little program. But for now, I want to just kind of have a short little program that I'm going to do something different with. And I'm not reading a max this time. I'm going to call it N. Chapter 4 introduces the idea of what's known as conditional execution. So the idea that sometimes you execute something, sometimes you don't execute something. So that's the title of Chapter 4, in fact. In the slides for today, I've included this slide that talks about what's known as the if statement. So we learned the for statement in Chapter 2. Now we're learning if. So the form of it is that you say, if some test is true, then execute some statements inside of curly braces. So let me give a little example here. I want to say, if n is even. Now that's not Java. That's not going to work right. We'll fix it in a second. But if we find that n is even, suppose that what you want to do is system.out.println even number. You know, that's we'll just kind of give that little output. That we'll say that it's an even number. Okay, so what we want here is a test. So we have to think about how to do a test. And how would we know something's even? I mentioned this before, that this is a nice application of the mod operator. What are even numbers? Even numbers are numbers that divide evenly by 2. So that means that the leftover when you divide by 2 would be 0. So we'd say that n mod 2 is 0. Those would be numbers that are even numbers. You know, and that's the way you might describe it in a mathematical way, is to say that this equals that. But remember, we use the equal sign for assignment. And so this is one of these annoying things, too, that you have to get used to, is that when you want to test for equality, you don't use equals, you use 2 equals. This is something that's known as a relational operator. These are introduced in Chapter 4. Relational operators basically are used to test relationships between 2 expressions. So there's kind of an expression on the left, an expression on the right, with a relational operator in between. You know, n mod 2 on the left, 0 on the right, with equals equals in the middle. So you're basically asking, evaluate the 2 expressions and see whether the resulting values have the relationship you've described there. So equals equals is a relationship you can have, an equality relationship. You can test to see whether something's less than something else, whether something is greater than something else. So those are relational operators as well. There isn't a special key that like the mathematicians use to do a less than with a little underline beneath it. So we use 2 characters. And if you just think of how you say it in English, less than or equal to, those 2 characters are doing a less than or equal to test, or greater than or equal to, they're doing a greater than or equal to test. And then there's another one that uses the exclamation mark with an equal sign. The exclamation mark we read as not. So exclamation mark equals is an operator that tests not equal. Something is not equal to something else. We'll be practicing these in Chapter 4 and Chapter 5, the different relational operators. They're in the slides, they're in the textbook. I think you'll get used to them pretty quickly. You know, just kind of remember things like using the double equals when you're comparing for equality. Well, let me compile this, and we'll run this little version. It's not a very exciting program, but if I typed in, say, 38, that is an even number, and it says it's an even number, which is good. If I ran it again and I give it a 17, it says nothing. So basically, this println was conditioned on whether or not I gave it an even number. And in the one case, it executed, and the other case, it didn't execute. The slides show you, after this slide, there's another slide that shows you a variation. Oh, let me just kind of point out, there's a little railroad diagram, again, that shows that these statements that are in the if, sometimes they're executed, sometimes they're skipped. You know, that's kind of the idea of the if. There's a variation known as if-else, where you give it 2 sets of code. So there's kind of a set of code to execute when the test is true and a set of code to execute when the test is false. So that way, something always gets executed, either what's over here or what's over here. So I can do a variation like that where I say, else I can say system.out.println odd number. So now I'm putting together what's known as an if-else. You can see kind of the suggested syntax there. There is no else statement, and else only makes sense when connected with an if. And the curly braces, there's different ways of doing it. We wouldn't mind if you did it in a slightly different way as long as you were consistent. But this is kind of the way that most Java programmers do their if-elses. Two sets of curly braces because there's two sets of statements. So I'm giving an alternative. I either want to execute the one println or I want to execute the other println. So if I give it something like 38, it says that that's an even number. And if I give it 13, it says that that's an odd number. So it always executes one or the other when we do an if-else. We're going to do a lot more of this in Wednesday's lecture. So that's kind of the if and the if-else. I want to use that to revisit a program that we did before. Remember when I ran this program and I think, let's see, what did I give it? I gave it a velocity of 400 pixels a second, 40-degree angle for 20 seconds, and it went zoom right off the screen. Well, what if I didn't want it to go off the screen? What if when it got to here, I wanted it to bounce off a wall and come back, kind of go in the other direction? Well, what's the position over here? You can kind of see, I mean, look in the lower left, and you can see it's an x that's very close to 600. Remember, this was 600 wide. And our xy was keeping track of the center of the ball. So you might think that this is kind of when x gets to be 600, but if it's the center and the ball itself is 10 pixels in diameter, we want to know when the center of the ball is 5 pixels away from the edge. So we'd be very interested in an x value of 595. So what I'm going to say is that if the x is greater than or equal to 595, so that means that it's basically gotten to the far right wall, then we want to turn it around in the other direction. If it gets over to here, we want it to go back that way. Well, you can do that by saying that the x velocity is set to minus the x velocity. We just turn it around the other direction. So we can end the old execution. And how about if we compile and run this one again? We give it 400 pixels a second, 40-degree angle for 20 seconds. And now it goes up to here, and boom, it bounced off the wall. But now it kind of went over here, and then it disappeared up at the top here. Well, what's that y value? That's the top, that's y of 0, but remember, as we're thinking about when the ball is kind of, this ball that has a diameter of 10, but then a radius of 5, when its center is getting close to a y coordinate of 5, so if y is less than or equal to 5, we would want to set y velocity equal to minus y velocity. Oops, and then that should be a closed curly brace. So that should get us kind of the other case we have here. Let's go ahead and compile and run this version of it. So 400, 40, and 20. And now it's going to come up here and bounce, go up there and bounce, come down there. Ooh, it ran off the edge here. Well, that's because basically these things are going to happen on either side, right? We're going to care, here we were doing y less than or equal to 5, but don't we also care when x becomes less than or equal to 5? So what I'm going to do is I'm going to throw in x less than or equal to 5. So I've got kind of two tests I want to put together. X being less than or equal to 5, x being greater than or equal to 595. And this is something we'll talk about more in chapter 5, but I'm going to put a little double vertical bar character here. That's an operator known as logical OR. So it's kind of saying if either of those things is true, it's going to switch the x velocity. And I'll do an OR here, y is greater than or equal to 595. So we'll kind of switch when we're on either side of the x or the y, and we can run it again and do a velocity of 400 at 40 degrees. How about if we go for 60 seconds? We'll let it run for a while longer this time. And it goes and it bounces, 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 bounces. So kind of the if-else allowed us, those ifs that we wrote allowed us to create a newer version of this. I don't know about you guys, but when I first wrote this program, I found myself just kind of staring at the screen. It's kind of relaxing, and wondering whether it was going to do that. Is it going to repeat what it's done before and come back to some of the same old spots? So anyway, that's a cute little program that we made nicer by having the console scanner to do input and using the ifs to have it do the bouncing. And we'll do more in the next lecture. This will be up on the calendar for today, along with those other examples.